Alright guys, so I'm going to go ahead and show you set builder notation. First thing you need to know is you need to know your number sets. These are something that you learned in junior high. We went over them in class, but you're going to have to get them down. Right here, this funky N, it's a double bar N, which if you're writing in just regular pencil, that just means it's a bolded N. It's the symbol for natural numbers, which are just your counting numbers, 1, 2, 3, 4, blah, 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 going out to infinity. The W, I didn't make a great double bar on that one, but it's really just a bolded W. That stands for whole numbers, which is your natural numbers plus the number 0. So 0, 1, 2, 3, 4 going out forever. No decimals, no fractions in either of those. No negative numbers, in fact. This double bar Z, the way I make the double bar, the integers, I make a 7 then an L. That stands for integers. That's going to be your natural numbers and your whole numbers, but now we're going to add the negatives in there. So like -2, -1, 0, 1, 2, and it goes from negative infinity to infinity. Then we have rational numbers, and I know I wrote an example kind of like it's going in halves, but really what a rational number is, it's a ratio of two integers by definition. It has all of your integers, all of your whole numbers, all of your natural numbers, but now it actually includes like 1/2, 1/5, 2/3, 2/7. It's all your fractions that you're familiar with. Then we have real numbers, and this is the one we're going to deal with more often than not here in Algebra 2. Real numbers are going to be irrational numbers like pi and e, meaning that they can never be expressed as a ratio of two integers, because pi is a non-repeating, non-terminating decimal, just like e is. Then 4, 2/3, it's everything above plus your irrational numbers. Basically, any number you could think of, and as long as it doesn't have imaginary on there, it will be a real number for all intents and purposes for this class. Of course, you have your irrational numbers. These are numbers that cannot be written as a fraction. The decimals don't repeat, they don't terminate, meaning they don't end, like pi, e, square root of 2, square root of 3, square root of 7. There's actually quite a few irrational numbers. We just don't deal with a lot of them in high school. And then, of course, we got our complex numbers, which is a C with a line through it. Means it's a bolded C, but it's a bar C. That's like 2 plus 3i, or just like 4i. You can have a real and an imaginary component, or just an imaginary component. Those are your number sets. Now, to actually build a set, we would use set builder notation. The way we're going to do that is we're going to use a curly bracket. It's going to be a set. Then we're going to define a variable. So let's say x, because we use x all the time. Then we're going to use a delimiter, which is just going to be a vertical bar, and we actually read that as such that. And then we're going to have to say, well, what number set is x part of? Well, in this case, let's say x is part of. In math, we say element, which is really kind of like it's part of, it's part of, let's say, the real numbers. And then we can have a constraint, because sometimes it doesn't have to be all the real numbers. We can say that it's going to be between -3, and let's say it's included, and then of course my x has got to be greater than or equal to -3, but then less than, let's say, 18. And that is your set notation, your set builder notation. As far as the way to read it, you're going to read the set of, this part is your x's, this reads such that, this part here is x is an element of the real numbers, this comma is an and that part you just write it as a compound inequality, and x is greater than or equal to -3, and x is less than 18. So this is actually a complete sentence. That's why if you notice, I did put a period on the end of it. I had a college professor that was a real stickler about that. I'm not a stickler about it, but you'll see that I do it all the time, and I wouldn't be surprised if y'all pick up and just do it yourself. But this actually reads as a complete sentence. It is a complete mathematical sentence. just to read it all together where it's not broken out. It's the set of all. This is all the set of all x's such that x is an element of the real numbers and x is greater than or equal to -3 and x is less than 18. What I want to have you do in class is not only are you going to practice saying it, you're going to have to practice writing a complete sentence in words. And then if I give you a sentence in words, you have to write the actual notation. This is kind of the gold standard as far as the type of notation used in mathematics. This is very formal. My daughter, when she was at LSU, her college professor didn't even require this. But if you know the highest level of it, you can always go down to what your teacher wants. So I want to teach you the highest possible level to this. Be very formal with it. So in future classes, if you don't have to be formal, they will ding you for being given them more than what they actually want.